See, remaining, let me take. Is my screen is visible to you?
Yes, sir.
Right. Now let me take one more. I will take one more example now to explain this one.
Yes.
I will take carbon. I have taken the bromine here, right? Here I am taking the CS3. Here I will take what? C2H5 means what? Ethyl group it is. This is what actually C3H7. That means around the carbon all are what? Different R groups here. See, methyl group, ethyl group, and here what your propyl groups are there. Different groups are there, right? Now in first step, what happens here? Anybody? In first step is a reversible process. This CBr bond will be cleaved. The bond will be shifted towards the bromine. You are going to get here what? Carbocation, isn't it? So here I am writing here ethyl group. C2H5 is nothing but ethyl group. C3H7 is nothing but propyl group. Do you know what is the meaning of C2H5, C3H7? Anybody have any doubts here regarding C3H7, C2H5 means? No problem, no. If I write C3H7, carbocation is forming, right? Correct or not? Up to here, any doubts you are having? Up to here, you are having any doubts? Are you having any doubts?
No, sir.
No doubts, no? Now this is carbocation is in planar because it is which type of hybridization? sp2 hybridization. So it is in planar nature. Now whenever it is in planar, what happen? It easily say what happen? You can see easily what happen? Attacks. Now nucleophile attacks from which direction can you say? The nucleophile attacks from which direction can you say? The nucleophile attacks in which direction can you say? Which direction? Left side or right side? Nucleophile attacks from this direction or this direction? From here side or this side? Can you say? Which is possible? Which is possible? Left side or right side? For example, if it is right side. This one is the left side. Are you there? Is my voice is
the right side.
Yes, sir. That means audible. My voice is audible. Okay, right. Now, if it is in any carbon, if it is on planar, means what happen? Left side, right side, both are what actually possible. Now, nucleophile can attack right side from 50%, okay, left side from 54%. For example, in your class, for example, there are two doors are there, two gates are there. One is front gate, other is what? Back gate. Whoever comes from back side, they will come by back side gate. Who will come from front side, they come by front gate actually. That means both are possible. 50% right side is possible, 50% left side is possible. Correct or not? Now, if it attacks on right side, what happens here? You are going to get like this. CH3, here you are writing C2H5. Okay, here you are writing what actually? C3H7. That means what I am writing here on this carbon, all these groups are what? Different groups. Now, nucleophile attacks here like this. Nucleophile attacks like this, right? Now, this is right side. Now, if attacks on left side, you are going to get like this. Nucleophile, you are going to get like this. This is C2H5. C2H5. This will be what? C3H7. Okay. One is right side, other is left side. Okay. Now, in SN1 mechanism, okay, if in SN1 mechanism, if carbon bonded to different groups, you see, One is C3H7, other is what? C2H5. Next one will be CS3. Then you will get two products here. One is called what? Dextro, can be shown by small d or plus. Other is called what? Levo, shown by what? Small l minus. This you have studied little bit only, not lengthy, only little bit in 11th class. Now these two called optical isomers. Racemic mixture also we can call optical isomers, racemic mixture, in which we are having 50% dextro, 50% will be levo. Dextro can be shown by small d or plus, levo can be shown as small l or minus. It doesn't mean that if nucleophile attacks on right side it is dextro. You can't say that one. Which is dextro and which is levo, that can be only identified by the, isn't it, spectrum, whatever the spectrometers say, optical rotators actually. So by seeing that we can't say dextro, but I have written like that. So based on plain polarized light, we can explain that one. I will explain later in the next class that one. So what I mean to say is that in SN1 mechanism, you are going to get the racemic mixture, because in examination you may get this type of question. SN1 mechanism, you are going to get racemic mixture. Now if I take something like this, CH3 carbon, CH3 Br in SN1 mechanism, same SN1 mechanism only. So how many products we get in this case? Can you say?
One.
Only one product. You don't get the racemic mixture. What is the product name here? Only this one. You may get product like this, CH3 nucleophile. The nucleophile may be OH or ammonia. Just now we discussed that one. But so 5 types of nucleophile substitution reactions we have discussed. So what I mean to say is that if the reactant is chiral, asymmetric center, if it is what? Chiral or asymmetric center, then only you will get the racemic mixture. That means all SN1 reaction mechanisms, you are not getting what actually? Racemic mixture. You are not at all getting the racemic mixture. When we get racemic mixture in SN1 mechanism, if the reactant, if the alkyl halide is, isn't it, chiral, asymmetric center, then only we are going to get the racemic mixture. Because in examination they will give like this. This is a SN1 mechanism. So do we get racemic mixture? No. We have to compulsory see whether the reactant is what? Chiral or this is not chiral, it is called achiral. This is called what? Achiral. Achiral does not give the racemic mixture. Normal product it will give actually. So this is the main thing you need to remember. Understood the mechanism now? Anybody having doubts now?
Sir, then for the other than chiral, the Nu will be on the right side.
See, if I say something, that also we will have discussions will be there in that one. So no problem. If I write like this, because in next class also we will discuss that one. It takes something 2 classes, no problem for you. Now you see these two compounds. For example, just imagine if it is dextro, if it is levo. Just imagine that. If you say what happened, racemic mixture. If you say something. Now, do these two compounds are same or different? They are what? Same only. They are what? Same. Nothing is difference is there. In plain polarized light, both will have same properties. But here, if you observe this one, these are not same. They are what? Different actually. These two are different. How they are different? Let me see in the next class. That is in the enantiomers topics. That is also there in the syllabus. That we'll discuss in the next separately. Here in this class, what I am saying, only SN1, SN2 mechanisms I will explain here. Okay. Now you have to remember this concept. If it is chiral only, we get the racemic mixture. Okay. If it is achiral, even though it is SN1 mechanism, if you imagine the two products like this, One is on left side, other is on right side, but both will be same. For example, if I take what happened, even though this one also, CS3 I have taken, carbon, CS3 I have taken, here I have taken hydrogen I have taken. Here I have taken the bromine or chlorine I have taken, no problem. You can take bromine or chlorine, anything. Again, if you do what happened, SN1 mechanism, how many products do we get here? Do we get racemic mixture? Yes or no? Do you get racemic mixture in this case? Do you get racemic mixture here?
No, sir.
Definitely no. Why? Because this is again a chiral only. Why? When you are calling chiral, if carbon, you see, observe, if a carbon, isn't it here? If a carbon bonded to different groups here, see here it is methyl group, here it is what? Ethyl group, and it is what? Propyl group here. Now here it is what? Bromine. So this is also what? Different bromine it is. Now then only you are calling this one as what? Actually chiral. So in that case only we get the racemic mixture. This point is important. Now you see here, these are same or not? Now these are what? Same. So now once if one is what? Same, that is called what? Achiral. They all are what? Same only. All are what? Same. So they are what? Actually, isn't it? Achiral. So this is the thing. Now, when SN1 reaction takes place, if you take what? The solvent, if it is what? Solvent, if it is what? Polar solvent, like water, if you take polar solvent, then which mechanism there takes place? SN1 mechanism. And if it is tertiary alkyl halides or even tertiary benzyl halides, tertiary halides, otherwise what happen? Benzyl, isn't it? Or allyl, then isn't it? They go for what? Actually SN1 mechanisms. Okay. This is about what? SN1 mechanism. Understood here? You have any doubt?
Yes.
Yes, sir.
No doubts. Shall I go to what? SN2 mechanism? Shall I go to SN2 now?
Yes, sir.
Right.
Yes,
Now
sir.
let's see SN2 now. Here. In SN2, it is called what? Bimolecular nucleophilic substitution reaction. Nucleophilic substitution reaction. In which what happened? Order will be now 2. Order will be 2. In the rate of reaction, it depends upon alkyl halides as well as what? Nucleophile. So the rate of reaction now also depends upon your nucleophile also here. For example, if I write like this, methyl halide something, I'm writing what happened? Methyl halide, CH3Br, reacting with what? Again, aqueous KOH. Now you are going to get definitely what happened? CH3OH, right? Now the rate of reaction depends upon methyl bromide as well as what here? Aqueous KOH. This is called what? Bimolecular nucleophilic substitution, simply called SN2 mechanism. Order will be 2 here. Now let me see the mechanism of this reaction. Mechanism of the reaction. For example, if I take what? CH3Br I have taken. CH3Br I have taken. So what I do actually here, I will write like this. Only no problem. I am writing the something Br like this. Here I am putting what? Hydrogen. Here I am putting what? Here hydrogen. Here I am putting what? Here hydrogen. Now this is the actually rate determining step, RDS step here. Slow step it is. Now the nucleophile attacking here only. The nucleophile is attacking in the slow step. In the previous case, nucleophile attacked on second step. But in this case, nucleophile attacks on first step. Now, can it attack on front side is possible? Front side attack is possible here. This is front side attack is possible. Reply. Front side is possible. My voice is audible to you? Is my voice is audible?
Yes. Yes, sir.
Front side is possible now. Is it possible? Not possible. So this is not possible. Front side attack never possible because this is a bulk group here. This is a bulk group. So someone is there on the gate, front side, front gate, watchman is there. That too, what watchman is what? Heavy, fat person is there. Something what gym person. The commando is there on front side. So you can't enter the school from front side because it prevents you. Back side, nobody is there. So you can enter from which side? Back side. Here it is free. This side is what actually? Free side from which, isn't it? The nucleophile attacks here. Now because of this, what happens? You will get like this here. Hydrogen, hydrogen, next one more hydrogen. Here, this is the front side. This one is what here? Back side. Now this we are calling as transition state. This is called what? Transition state. So transition state cannot be isolatable. Remember, transition state cannot be isolatable. You can't isolate. Just imagine this one. In here, it is actually this bond is getting breaking. This bond is getting breaking, and this bond is getting what? Forming actually. So generally, carbon do not have the 5 bonds. How many bonds are there? If you observe here, 5 bonds are. But actually, there are 3 bonds are there. 1, isn't it? 2, 3. But remaining one, they are getting that one. This bond is what? Getting breaking. This bond is getting what? Forming actually. So this state you are going to got transition state. Now again, if you observe in SN1 mechanism, you got carbocation. Okay. In the SN2 mechanism, you are getting transition state. After this, what happened? This bromine is completely what? Breaking. After that, you are going to get here hydrogen, 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 and what you are going to get here? Nucleophile. This is the product you are going to get. Okay. Now, if I take what happened again, different groups I'm taking. I'm taking what? Different groups. Bromine, hydrogen, deuterium, tritium I'm taking. Understood here? These are different groups or not? Tritium, deuterium, hydrogen. All are what? Different groups now. That means it is also what? Chiral center. It is also what? Chiral. Now, what happens here in RDS step here? In RDS step or slow step, this bond is getting breaking. Now we are going to get, no, sorry. Now what you are going to get? Nucleophile is attacking from which direction it can attack? This is bulk group. Bromine is what? Bulk. When what's atomic number of bromine? 35. Atomic number of deuterium is will be only 1 only. Now this is the being as bulk group, isn't it? Nucleophile attacks from the back side here. So we are going to get a transition state like this. Hydrogen, deuterium, this one is hydrogen. Next, what happened? Tritium. Here, this bond is getting broken, and this bond is getting forming actually. Which one it is? Nucleophile bond is forming. Transition state we got. Transition state. Now, finally, what happened? The last step, what happened? This bond completely will get broken here. You are going to get like this here. D. This one is what? This one will be what? D. This one will be the H. This one will be the T. And this one will be the nucleus. Now, if you observe what happened here. Now, in the chiral center, the bromine is on left side. Correct or not? Left side. But in this, the nucleophile attacks on which side? Back side. That means here the configuration is inversion of configuration. Inversion of configuration is forming. This is called Walden inversion product here. Now, Walden inversion product where we get in SN2 mechanism. In SN1 mechanism, racemic mixture is forming. In SN1 mechanism, racemic mixture is forming. In SN2 mechanism, Walden inversion is forming. Now, in the next class, I will explain what is inversion of configuration, how this is forming, okay, how this is forming inversion, what is this D and L, how to get the reverse, that I will explain that later in the next class. But here in SN2 mechanisms, isn't it, this will be order will be equal to 2, and this will be the mechanism, and this will be the actually with chiral. Now remember, a chiral does not give the Walden inversion product, it will give a simple product, okay, a simple product we are going to get. But in, if you take chiral, you will get the inversion, only one product only, here also only one product only, but that is in inversion product here. So how to get the inversion configurations, I will discuss in the next class actually. So now next slide, if I move, what happened, next slide I'm moving actually here. In the next slide, what I'm citing here, I will do one thing actually. Only small exercise I will give you. Within 2 minutes, we complete this one. In this case, I'm writing like this: CH3Br, CH3, CH3, CH3Br. Okay. Now one more I'm writing: CH3, CH2 iodine, CH3, CH2 Br, and CH3, CH2 chlorine. Now tell me, among these 1 and 2, which will undergo SN1 and which will undergo SN2 mechanism? Among 1 and 2 here, which will undergo SN1 and SN2. If you complete this one, I will leave you. Otherwise, what happens? You have to stay with me. Do fast. CH3Br, and this is what? CH3, CH3Br. Which will undergo SN1? Which will undergo SN1? First one will undergo what type of mechanism? First one.
Second one.
First one is what type of alkyl halide? Primary alkyl halide. Therefore, readily it will undergo SN2. Dominantly SN2. I'm not saying SN1 takes place. SN1 also will take place, but domination by the SN2 because it is a primary. What is the reason? Because when nucleophile attacks, no. In that case, when nucleophile attacks, these groups must be small groups, no. Whatever this group must be what actually small groups. When we get a small group, if you have hydrogens only, we get a small group. So that is the reason when you write SN1 mechanism, SN2 mechanism, it must be primary. Now what about this one? This is a tertiary alkyl halide. In tertiary alkyl halide, you are going to get what mechanisms? SN1 or 2?
SN1.
SN1 only. What is the reason behind this one? You observe here. You are getting carbocation in the SN1 mechanism, right? You are going to get a carbocation in the SN1 mechanism. Carbocations are stabilized by the alkyl groups. Here, this is stabilized by which groups actually here? Alkyl groups. These are plus I groups. These are what? Plus I groups. Plus inductive groups here. They stabilize. In the 11th class you have studied here. Plus I groups stabilizes the carbocation. That is the reason we need have some bulk groups like this. Stabilizes the carbonium. This is the thing actually. This is the reason actually they are taking place here. Okay. Now what I mean to say is that here, if they given like this, you can easily select. Now here in this case, which is readily undergo reaction? Or SN1, SN2. Generally they undergo SN2 mechanism. Which will undergo readily? Can you say? Iodine or bromine or chlorine?
Iodine, sir. Iodine, bromine, and chlorine.
What is the reason?
Sir, living nature of iodine is very high.
Iodine readily will be cleaved. This is the best living group when you compare with remaining. The Ci bond energy is what? Less. Bond energy is what here? Less here. So this bond readily cleaves here. Bond energy less, what happened? It takes place readily here. But in the case of CCl bond here, bond energy is what more here. Therefore, to cleave this bond like this, it takes more energy. So it will take slowly like this. Slowly means what happened compared to this one slowly. Okay, in this way you are going to have in your textbook. Show you what to take exercise from the textbook here. Okay, now this I will send you. No problem. Just I will save this one. Next we will see the only I will show exercise. You do you have a textbook with you now? All of you are having textbook with you now?
Yes, sir.
Yes.
Open that no textbook, all of you. Now this screen is visible to you know? This PDF all of you.
Yes, sir.
Now here you
Yes,
see now you have to first you open you read
Yes,
after
sir.
okay after finishing of class what happened you read this nucleophilic substitution reactions SN1 SN2 mechanisms are given here. So this one you have to read here nucleophilic substitution reaction here. This part you have to read nucleophilic substitution reactions. Now this I will explain the later next class I will explain this one here no need to read this one. Okay, right. Now this is the mechanism of SN2 mechanism. This is the SN2 mechanism. You just note down this one. Then this one will be the SN1 mechanism. You have to note down this one here. This is achiral. Here we don't get the racemic mixture. Remember, this is achiral. Here we don't get any racemic mixture. Remember. Next, this is the order of reactivity. Observe what happened for SN1 mechanism. For SN1 mechanism, tertiary halides are more reactive. For SN2 mechanism, primary halides are more reactive. Correct or not? For SN1, tertiary what? More reactive. Okay, here we have some questions are given. This order of reactivity for alkali. Just now we have taken a problem on this one also. Now you observe here, example 10.6, you can do now SN2 reaction which is faster. Okay, so this one you can do and 10.7 also you can do here. Try to solve this problem. Okay, there are answers are given, but you need to solve own. This stereochemical aspect. Okay, what are these chiral centers? Everything we'll discuss tomorrow class, right? So next thing, one more thing is this inversion of configuration. Also, you can check here. This one also, if you want to do this one, you have to check. Tomorrow I will explain this one here. Finally, we'll see some exercise here or there. Here exercise is there 10.7, 10.8. These you can do now. You have to do this one as exercise. Okay. Complete this exercise today itself. Okay, today itself you need to complete these two. It takes only roughly what 5 minutes only, not more than 5 minutes it takes. Okay. Now this one also you can take as exercise 10.9, 10.9 SN2 mechanism here. Okay. Okay, this is only we can take today's. Now, if you have any doubts, you can stay with me. Otherwise, what happened? You can log out now.